Hey guys, welcome to Advanced Math 1.3. Today we're going to talk about multiplying expressions. Our life application from this is that the student will examine the foundations upon which he builds anything in his life, academically, socially, physically, and spiritually. We're building the foundations of math. We know that we need to have a firm foundation, but we also should examine more than just the foundations of math. Our lesson objective is that you, the student, will use the distributive property to simplify algebraic expressions. Now, if you've forgotten what the distributive property is, let's take a quick look. For any real numbers a, b, and c, a times b plus c is the same as ab plus ac. We can multiply that outside number, a, by anything inside the parentheses and then add those two parts together. The distributive property is often used to simplify algebraic expressions. Now let's put some numbers in here to show you how it works with numbers. Let's say I have 3 times 2 plus 5. And that's just 3 times 7. That should be 21. I can distribute that 3 and do 3 times 2 plus 3 times 5. 3 times 2 is 6. 3 times 5 is 15. And 6 plus 15 is 21. 3 times 7, 21. So we can see that's how that works. It's really helpful when we don't have numbers inside the parentheses, but we've got variables instead. Here's an example. We're going to distribute 4 times a plus 3b. We can distribute that 4 to the a and have 4 times a and distribute it times the 3b and have 4 times 3b. Simplifying that gives us 4a plus 12b. We can't combine those terms anymore because they don't have like variables. They are not like terms. Let's distribute that negative 2 times 3x squared, negative 4x, and 5. Try that one on your own. Pause the video and see if you can get it right. When we distribute that, we end up with negative 6x squared plus 8x minus 10. We have 3 different terms. None of these are like terms, so that is as simple as we can make this expression. Let's take a look at a definition of a term. A term we've looked at before, but here's a reminder. It's a constant, variable raised to a power, or the product or quotient of a constant and one or more such variables. So, just in case you're not sure what those are, it's a constant, that's just a number, a variable raised to a power, whether it's 1, 2, 3, 4, 5, any power, or the product, that means multiplying, or quotient, that means dividing of a constant and one or more such variables. So 7x3 to the third power is a product of a constant and a variable, and x cubed over 7 is the quotient of a constant and a variable. All of these count as terms. So let's simplify 3k times k plus 2 minus k times k minus 1. We're going to distribute that 3k here, and we're going to distribute the k here. Try that on your own. Pause the video, then come back and check. We know that any number times itself is just squaring it. 5 times 5, that's 5 squared. When we don't know the number, like k times k, we would write that as k squared. So we've got 3k squared plus 6 squared minus, our operation stays here, k squared minus times that negative 1 there. Okay, so negative k times positive k is negative k squared, and negative k times negative 1 is positive 1k. We don't have to write the 1 in there. It is implied, but we can write it there if we want. Now we do have some like terms that we can combine. We've got a k squared term here, and we've got a regular k term here and here. So we can combine those to simplify to 2k squared plus 7k. At that point, we can no longer add or subtract these terms because they do not have variables with the same exponent. Try this one out. Pause, try it on your own, and come back. Well, we've got to distribute this 4y here inside. And once we've done that, we can combine like terms. Now this 3x and this 4x are underlined because they are like terms. So let's go ahead and combine those inside the parentheses. Outside the parentheses, we've got a negative. And this 1 again is implied. When we put an operation directly in front of a variable or directly in front of a grouping sign, that 1 is implied. So we've got to distribute that -1 to everything inside this parentheses, which makes it 7x squared plus x minus 8xy plus 32y squared plus 5xy. It's really important when you're using the distributive property to pay careful attention to your signs. One wrong sign can end you up in the wrong place in a graph or in the wrong place in a problem. We're going to continue to combine our like terms, and we now have 4 separate terms, and none of these terms have the same variables with the same exponent. So we are done. Do you remember the FOIL method? When we're distributing or when we're multiplying binomials, FOIL stands for first, outer, inner, last. First, outer, inner, last. When we're multiplying binomials, each of these is a binomial because they have 2 terms. We're going to multiply the first terms, and then we're going to multiply the outer terms. So that's A times D, and then the inner terms, which is B times C, and then the last, B times D. Now, some people prefer to write this a different way. I don't know if I can fit this on the screen, but I'm going to try. Some people prefer to write it like this. They make themselves a little chart here. A times B and C times D. And we're going to multiply A times C here. Well, A times C is just AC. And in this box, we're going to multiply C times B, which is CB. And then we're going to multiply A times D, positive A and positive D, AD. And then in this last box, positive A and positive B, which is BD, positive BD. So we've got 4 positive terms we're adding together. That's a different way to FOIL. If you prefer that way, you can try that out and see if that works for you. Let's take a look at an example. Got to multiply these binomials on your own. Pause the video. Come back when you think you've got the answer. Doing it the traditional way, we're going to multiply our first terms, x times 3x, to get x squared. Our outside terms, x times y, gives us xy. Our inside terms, we multiply the coefficients. 2 times 3 is 6, and y times x is just x times y. And our last terms, 2y times y is 2y squared. If you did this the chart way, like I just showed you, we have a positive x and a positive 2y. And we're multiplying that by positive 3x and positive y. So all of our terms are going to be positive here. 3x times x is 3x squared, and 3x times 2y is 6xy. Y times x is yx, and y times 2y is 2y squared. So either of those ways, you're going to end up with the same 4 terms. Remember, we can only combine terms that have variables, same variables raised to the same power. And we've got an xy term here that we can combine. After that, we've got an x squared, a y squared, and an xy, so no more variables with the same exponents. Try this one on your own. Come back and see if you're able to do it using either one of those methods. Multiplying that, we get 24a squared minus 60ab plus 6ab minus 15b squared. Using that first outside, inside, last, we can combine our ab terms because they have the same variable with the same exponents. Sorry, I went too quickly there. Our final answer is 24a squared minus 54ab minus 15b squared. Again, watch those signs. Now, we do have a negative sign. Let me show you how that works in this chart. We have a positive ab, and we have a positive 3b. And we're going to multiply that by positive 2a and a negative 5b. Well, positive 12 times positive 2a is 24a squared. Positive 12a and a negative 5b is negative 60ab. So you can see that negative sign is going to work its way in there. So that might help you to keep track of those signs if you do it that method. If you're having trouble foiling, try the chart, see if that works better for you. Today we use the distributive property and FOIL method to simplify algebraic expressions. We also use a multiplication chart to help us multiply binomials. If you're having trouble remembering first, outside, inside, last, or if you're getting your signs mixed up, this chart is a great way to multiply binomials. In fact, you could extend the chart and you could even multiply trinomials with this and other polynomials as well using this chart. I think it's a great way to keep your signs straight if you're having a hard time keeping your signs straight and remembering first, outside, inside, last. If you guys have any questions, don't forget to ask me next class.